All right, let's do this. So it's very nice to meet you guys all over Zoom. I had the pleasure to meet some of you guys at KubeCon in Paris last week and others virtually. It's a pleasure to be able to talk to you and to present to you some of the very cool findings we have found here at CastAI and give you some good hints on how you can cut your Kubernetes cost. So first, our speakers. So myself, I'm co-founder of CastAI. I run product and business for the company. I started the company in 2020. It's a pleasure to be here. I have with me my dear colleague, my dear partner and dear friend, Achi Solomon. Achi, you've been 20 years in this business, the last 10 as head of DevOps for one of the most beautiful company and user of Kubernetes, Yotpo, based in Tel Aviv. Achi, welcome and stay.
Hi.
Very nice to see you, Achi. And then I have my dear friend Scott, who is a founder and chief analyst at Futuriom. Scott, if you'd like to introduce yourself. Scott, you're on mute.
It helps to unmute. Yeah, thank you. As you said, I'm the founder and chief analyst of Futuriom, and we are an independent research firm following cloud and communications infrastructure.
Scott, it's a pleasure. We met a week ago, and it's a pleasure to have you here. All right, let's do this. So something we do every year is a Kubernetes cost benchmark report. Well, I say every year, but that's the second time we do it, the second year. We did this in 2023, and now we did in 2024. It's very interesting. I'll present to you some numbers there on what we see as the average utilization of CPU and memory for Kubernetes and why there is over provisioning and what to do about it. So first, before we start, the source, I mentioned this because you guys have to see how relevant it is. We did it on about 4,000, a bit more than 4,000 clusters that we analyzed, and we selected clusters that have more than 50 CPUs. That means they are relevant in size and they have a good representation of what the state of Kubernetes is. We did this for analysis of last year. These clusters were analyzed before any kind of optimization. So these are really organizations that come to us and say, hey, we'd love you guys to see how we do with cloud cost. And these are all before we start to work with these organizations. The data also include the three major cloud providers, AWS, Azure, and GCP. And mostly all over the world between Asia, Europe, Africa, and the Americas. So it's very representative of the state of Kubernetes and give you a good idea of where are we in the journey of optimization and what's the average potential these clusters have. Before we start, I'd love for the audience to give us their estimation of what's the average CPU utilization that you think you may have in your Kubernetes cluster, so in your cloud native application. So Alexei, if you can run the small poll, and you guys just select one of those. I think you have 10%, 30%, 50%, 70%, and more than 90%. So that means what's the average utilization of compute resource you think you may have on average with cloud native and your clusters. So I'll just leave this for another few seconds so you guys can answer one of these questions, and then we look at your result, and then I'll show you what we found with our 4,000 clusters. So, okay, if you guys have finished, Alexei, if you can close the poll and show us the result. And what is the result? Okay, the result is the following. Oh, it's super cool. So 10% selected 8% of respondents selected the 10%, 46% selected 30, 27 used 50, and 19 of you guys selected 70%. Nobody did the 90. That was there on purpose. So if I see this, I guess a good average is anywhere between 30 and 50%. That's what probably is the consensus of the group. I'm going to show you the real number. Now, the number the statistically relevant number on 4,000 applications. And this is our result. The number is 13%, 1-3. And frankly, guys, I was as surprised as you voted in this result. So think of this as this is a statistically relevant study. It's not a survey, this one. It's a study, statistically relevant, on 4,000 clusters that have more than 50 CPUs. So they are representing a good chunk of what is cloud native on 3 cloud providers. And it shows the following. Out of 100 CPUs that you have in these clusters on average, you are only using, or we are only using 13 of those. If you think this way, it means that the average over provisioning is 8 times. So on average, if I use this number and I rephrase this in English, on average, we as practitioner, DevOps practitioner, are over provisioning our Kubernetes clusters by 8 times over 1 month on cloud native applications. When we did this study, it's not a survey. When we did this study, we start to feel, is it the same by cloud provider? It's roughly the same. So meaning Amazon is a little bit less, it's 11%. Azure is very close by, 11%. And Google is slightly higher at 16%. Anyway, it's bad or it's bad because it's not great between these two. So that's for CPU. CPU is something that we pay a lot of attention to because it's the most expensive component on running a Kubernetes cluster. Number one is CPU by far. Then you have memory, and then the third one is network and storage, usually similar between network and storage, typically. All right, so it's 13%. Then we also looked at memory. And memory is a little bit better. It's 20% memory utilization. So the same, out of 100 gig that you may have, you only use 20 of those. You don't use the other 80. Let me say it differently. You have never, ever used the other 80 on average over a month. That's what that means. Now this number is exactly the same. Doesn't depend on the cloud provider. It varies between 19 and 21. So it's roughly the same number. So AWS, Google, and Azure are identical. What surprises me is that I was expecting CPU to be higher than memory. And the reason is if you run out of memory, and Ari, I'm sure you know a bit of this. If you run a bit out of memory, well, your container breaks and has to restart. That's the feared OOM out of memory error. So I thought the overprovisioning of memory would be higher because we want to avoid that error, that OOM error. It's not, and I'm thinking the reason could be that we pay more attention to memory. And by paying more attention to memory, we actually have less of a provisioning on it. That's my explanation. It's hard to tell if that's true or not, but it's statistically significant that there is less of a provisioning for memory. But anyway, it still is 5 times more than it should be on average over 1 month on any of these cloud providers. So that's where we start from in the world of Kubernetes. The last statistics is one that also surprised me a lot. So the number I showed you before, CPU and memory, is the real utilization, right? You measure on these machines, these VMs, how much CPU and how much memory I'm using on average. Then we looked at what is the gap between provision, so what you have, what you pay, and requested. The requested amount of memory is what the developers believe they need when they deploy the application. The wall of Kubernetes is great. It says, well, if you tell me what you need, I will supply at least that number. That's what requested CPU means. That's why it's such an important component. When you deploy an app, you have to provision at least what you think you need, and that number is requested. What's surprising is the over provisioning, you can call it the headroom between requested and what you really have, is actually higher in 2024, or I mean this year over last year. And it's also statistically relevant. And frankly, that surprised me. It means that we are wasting a lot of money. We're over provisioning a lot for Kubernetes, and it's actually worse, not better. It was 37% in 2022, and it's 43% on average for the whole year, for the whole of last year in 2023. We spent a lot of time to try to understand that, because we felt, well, Kubernetes is becoming mainstream, then there is more practitioner that use it. Therefore, we should be better at using Kubernetes and better at provisioning it. What some of our friends in the industry are telling us is, yes, it becomes mainstream, but because it's mainstream, you have a lot more people, a lot more DevOps engineers, a lot of developers using containers, and those guys are new in the cloud native, and therefore the over provision is getting bigger, just because it's hard to do it, and it's hard to do it for new players in the Kubernetes space. That's what analysts have told us. Scott, later on, maybe you can let us know what you think about this, if you believe the same. That's what we heard. And frankly, it's weird that there is, on average, more over provisioning or more headroom now than it was a year ago. All right, so that's the numbers we found. Then we at CastAI, we built an AI engine that take all these numbers of over provisioning and is trying to fix it and solve it. That's what we do. We optimize in real time and try to provision only what you need in real time and modify these numbers as your application is being deployed. So what I'm going to show you now is what is driving this over provisioning. That's what we see again, right? These are not surveys. These are real hard data that comes to us. The first one is the one you just saw, the vast over provisioning. Yeah, if you use only 13% of what you pay for, then yeah, that's not a great number. The number one is the one you saw as well, the unwanted headroom. So the fact that you're requesting, you're provisioning, or we are provisioning, us as an industry, over provisioning a lot more CPUs than we think we need. So the unwanted headroom, I can't say this in English, unwarranted headroom means we over provision what we think we need. The vast over provisioning is we over provision our best guess by a factor of 8 times. In the world of cloud cost, the third option, which I haven't shown you as a statistic analysis, but this is something we have in our number, is the fact that we are very often using expensive machines while we could use a lot cheaper machines. And Ari will have a great example with this. It's this one. Very few organizations use pricing arbitrage. In particular, there's a very low spot instance use. And we saw this because all these clusters that come to us, the vast majority of those use very, very little spot instance. Spot instance is a great way to do pricing arbitrage, but not the only one. And I'll mention one example. AWS have about 600 different types of machine. Think about the following. Some machines have Intel processor and others have AMD. In many cases, the performance is identical between an M6i, which is Intel, popular Intel machine on AWS, and an M6a. A is for AMD. They're very similar. They're not exactly the same, but they're very similar. However, the AMD machine is cheaper. That's the policy of AWS, to make AMD machine cheaper. You can replace AMD by Graviton, and very often they are cheaper as well. Yet, very few organizations use that as pricing arbitrage. So these are the three levels you can use. Over provisioning, it's huge. It's 8x. You saw it earlier. The unwarranted headroom between the amount of CPU requested and the amount of CPU that was provisioned, and the fact that we tend to use expensive machine while we could use cheaper one. So the way to fix it, there's no surprise here, is with automation. So if you can have an engine, a smart engine that can do pricing arbitrage, that know how to do pricing arbitrage and understand exactly the performance and the amount of compute you have according to a particular CPU, and then look at the price of those and arbitrage this between spot and on-demand or spot and reserve instance, then you're going to reduce your cost by a lot. And Ari will show us an example at Yotpo. But that's not the only one. The other one is when I say I need 2 CPUs for my containers, when I say that my amount of requested CPU is 2, is it really 2? No, it's not. In fact, it's 13% of that. Great. Why don't we set the amount of requested CPU the right way? Instead of making an estimation, we use an engine that autonomously will come up with the right amount of CPU that this container requests based on the observability of that container. That's the second point here. Set the right request to fight cloud waste while maintaining performance, which is the right sizing of the workload. Once you know how many requested CPU you need, then you have to select the right type, the right size, the right number of instances. We call them nodes in our world. That's the first bullet point. Then you have to do this in real time because your application is moving. Let's say that your users are sleeping at night, so they don't use a lot of this, but they wake up in the morning, they start to use your app. So you have to do real-time adjustment of this. The word we use for that is called bin packing and autoscaler. You have to be able to go up and down very, very fast as your application need more resource or does not need a lot of resource. So it's when you combine these 4 things that you're able to increase your utilization rate and reduce your cost. And when you reduce your cost like this, it is substantial. He will show us his example at Yotpo. You're going to see how substantial that can be. This is the result of it. I like this because it's very visual. So what you see here is what I'm showing to you here is the blue line is the amount of CPUs that was provisioned to run this. This is a 24-hour of cycle of an app. This user is based in Asia. This is local time. So you can see that in the morning, their user wake up. So the amount of CPU the application need will increase, which you can see here. Then these users go for lunch. So they use less the app for lunch. You have a dip. They go back in the afternoon, and then they go back to sleep at night. This is typical of the usage pattern of any human-based or human-created application in the planet, whether this is a cybersecurity company, it's a e-commerce, it's a bank, it's a manufacturer, it's going to be the same pattern. It's low at night, high during the day, low at night again. What you see in blue is what was provisioned by the Kubernetes engine before optimization. This one is on Google Cloud. It's GKE, but it's the same on the other two. There's absolutely no difference. The difference between blue and yellow, that's going to be your waste. You provision the blue, but you just need the yellow. This is what an AI engine does when you submit this and try to fix it. What it does is it says the following: well, if you need this yellow thingy, I'm going to supply exactly that. This organization have a 20% headroom. That's why the blue is about 20% or 10% higher than the yellow. It's a real-time engine. So you see when there is a dip this time at lunch, you have more users. That was not the case the 30th of September. That's the case after. Great. It's a real-time engine. So if it sees that you need more, great, I'll supply more. But the minute you don't need this, I drop it. That's what the AI engine does. It's an engine that looks like a DevOps engineer. It's powered by AI. It runs 24/7. It's obsessed with these 2 lines. Another thing it does is when you need to add these CPUs, well, let's add the one that is the most cost efficient. these guys use spot instance. So anything that is above the 800 or 900 CPUs, which is kind of your reserve number, is on spot instance. It's not that they do that by hand. It's that they told the AI engine, please use spot instance when you can, if they are cheaper, if they are better than the reserve instance you may have. These clients also changed their reserve instance to about 1,000 because they felt, okay, the only thing I know for sure is that at night, there is between 800 and 900 CPUs. That's kind of the minimum for the application to run. So I will buy reserve instance for those because I know I need them anyway over 24 hours, over months. And then whatever is above, they use pricing arbitrage, which in this case will result in using spot instance because the app run nicely on spot. Because it's a real-time engine, we add them and then we delete them when we don't need them. So you see, morning we add them, in the evening we delete them. We delete them almost as fast as we can add them. That's the bin packing in action. The fact that you have a few, probably 300 or 400 machines, nodes, around 6 p.m. The AI engine says, oh, I don't need all this. I don't need all these CPUs. Which node can I delete fast because I don't need them anymore? Remember that in the world of Kubernetes, these nodes are still busy. They still have containers inside. They just don't have a lot of them, right? They may have only 10 or 20% of their utilization because all the other containers have disappeared. They're not necessary anymore. The AI engine is doing the bin packing in real time. So it's looking at, oh, these 20% nodes, these containers on this 20% node, I can actually move them. And if I move them, nothing will happen. Nothing will happen means there will be no performance impact because these containers are highly replicated. The engine knows all this. So it makes these decisions in real time. It says, oh, I don't need all these containers. I can empty that node. I can empty that node without any performance. I'm going to do this. I'm going to do this very fast. And I'm going to do a few hundred at the same time. And that is why you see the curve going down so fast. This ultra fast, smart bin packing, autonomous bin packing that makes these decisions in real time. So that's an example of automated optimization on a real use case. What I would love to know now from Scott and from Ari is what is it that they see in their line of business? I know, Scott, you speak to a lot of organizations as you are an analyst at Futuriom. Why don't you tell us what you see in the market, in the space?
Sure. Well, I think you touched on a lot of the issues. The main one is that a lot of these technologies are quite new, right? And people are doing things manually. So your value proposition is simply to automate things that are done manually. I did think it was interesting you pointed out the headroom issue of the 13% utilization, and you had these theories about why that is. It seems like maybe some of it is just safety. We don't want to run out. We humans are hoarders, natural hoarders, right? We want to stock up on things. So maybe people are afraid of losing their jobs because if they run out of compute, that's a bigger error. Uh, but I would defer to Ahi, who actually has to do this for a living, right? I'm just an analyst, so maybe he can explain the headroom issue and how he came across it.
So in our place, what happened is in the early of 2023, we simply saw an increase in the compute cost. We didn't know where did it come from, and it was like 10% a month, and then another 10% a month, and another 10% a month, and I'm like, whoa, what's going on here? So we started to analyze it, and we like in Yotpo, most of the compute power that we use with spot in instances. So what we witness is that the price of the spots is simply increasing. And we're like, okay, what do we do? What do we do with that? Like we moved 80% of our workload from on-demand EC2s into Spot. We thought that we are very, very efficient, very, very cost effective. But then the price of total spots simply started to raise, and then we started to see that there are differences. There are differences between AZ. So if I take the same spot, the same instance type, and I just move it from US East AZA to AZE or AZD or AZF, then the price drops in about 30%. And I don't care in which AZ it runs. I care about the region, but I don't care about the AZ. So yeah, let's move it. Cool. And we saw that basically we're not sure like what is the best cost-effective instance type for our workload. So we've done manually. So we manually moved from one AZ to another, and then prices change all the time in the spot market. So we have to run across the AZs and like once a week, okay, what's the best cost-effective AZ right now? Okay, let's go there. And then that's manual, okay. And then second thing is that we saw that there are instance types that maybe will not fully utilize the instance type, but for our needs, there are bigger instances for less cost, which to me it was it was a surprise because apparently no one wants the big spots, the 16 XL spots, the 4 XL spots, the 8 XL spots, the 32 XL spot. No one wants them, so they have a very low price. So we looked at, okay, how can we consolidate more of our resources, more of our pod into bigger instances, which will actually cost less. So for us, it was quite a big surprise. So just without even talking about the headroom that Laurent has mentioned before, just changing the availability zones and just changing the instance type, we started to do it manually, and we saw that we can reduce it dramatically. But then we said, okay, we cannot keep on doing this. This doesn't make sense. Like it always changes. We have to find something automatic that will do it for us. So we started the search. My first option was actually Carpenter. So started with Carpenter, and then with the best the one after Carpenter was Spot.io. They have like the big name. And then we also saw Cast, and we saw also ScaleOps and PerfectCell, and we created like a huge list of our requirements. I basically listed 2 of them, but I have something like 30 in the requirement list. And then we started to compare each one of them. And the main points were, please change my AZ, and find me the best AZ for my instance, and find me the best instance for my workload, okay? And pack it together. I want it to be packed as much as possible. We had also other requirements. Maybe we'll talk about them in the after. But this is where we started to do that, and then we started to do POCs with them. And once we've done the POC with Cast, then we saw that we were able to reduce about 30% of our compute, between 30% and 40%, depends on the workload, of the compute cost per workload, which is, in my eyes, amazing. But I'm like one organization, and maybe Scott, like you have a wider spectrum, you know, a whole lot more of a organization than me. How do other organizations do this?
Yeah, I mean, this is happening everywhere, right? This was last year. I don't know if everybody remembers Mark Zuckerberg at Facebook declared it the year of optimization, right? So I guess everybody listened to him, right? And everybody went back and looked at their cloud costs, which were, as you explained, getting out of control. So they looked at all these automation technologies, which are exciting because they're new. Cloud cost management is a relatively new industry. I find it interesting that you looked at all these different products and services, and you talked about your list of requirements. What was the key differentiator for you, either for Cast or for anybody? What's because there's a lot of products on the market for this now. What is the key differentiator?
So I want to touch on the key differentiator, but I see a question from Alexei. I think it's Alexei, if I'm pronouncing it right. What about cross AZ traffic? So I mentioned a huge list of requirements. One of the requirements in the list, we have Spark jobs, lots of them. And in the Spark jobs, we have the one that is spawning the jobs and all the jobs themselves. And if you have them in different AZs, then your network cost is going to explode. So I've gave Cast AI a very hard life, and I'm still am, actually. And one of the requirements that was raised for the Spark, specifically for Spark workloads, is to make sure that we run workloads in the same AZ, so that we will have like buddies, that they will jump on an AZ, on the best AZ for the whole pack of workloads together. And this way, we basically eliminated network cost. Now, I will say that network cost is still a pain. It's a pain. It's not really solved yet, and Laurent knows this. I know I'm picking on him. The last week in KubeCon, first thing that I meet Laurent, what about network? So it is still a network. It still is an issue. Regarding your point, Scott, so our biggest fear was Black Friday. That was our biggest fear. Because what happens in Black Friday, we get a huge peak of demand, and it's like it's a very short time frame. And we need, like, we want to be on spot because it's cost effective, but it's Black Friday, so everyone wants spot, so there are no spots. So there is an automatic mechanism in AWS that will fall back from spot to a on-demand machine, which is great. But what it will not do, when there is a spot available, it will not bring you back to a spot. So it's like one way to pay more. That's what it is. And so that was one pain. And from robustness perspective, like if we don't serve our clients during Black Friday, that's a huge no. Like this is the money time for us, literally the money time. Yotpo is the e-commerce company. We make our business in e-commerce. This is Black Friday, Cyber Monday. That's the money time. So we need to know how to scale up very good and scale down very good. And these are like the main events. And so another requirement from that list was what happens when cost is down? What happens? Like we cannot afford it. We cannot afford that in Black Friday when demand goes up. Cost is basically our cluster autoscaler, and if it goes down, what do we do? So sorry, Laurent, we didn't trust you. We tested ourselves, and we found issues, and they were fixed, and we found issues, and they were fixed, and until we weren't like totally safe, we didn't go through with it. And I can say that now we are after Black Friday, and our Black Friday and Cyber Monday were the smoothest in the last 10 years.
Oh,
So
wow.
yeah, so it did the auto scaling. It was smooth. It did from spot to on demand and back. It chose the right instance for us. It reduced the whole cost of the whole event. Like before what you said that other customers are doing it manually. So Black Friday in 2022, what we've done is we've taken half of our workloads and manually moved them from Spot to on demand. So that's like huge amount of manual work before Black Friday. And 1 week after Black Friday, move them back from on demand to Spot. So again, a lot of work. All organization was actually doing it. I see another question. Do you see an impact on performance when you optimize Kubernetes cost? An impact on performance? No, I don't. I don't. I don't see any impact on performance because, like, the request and limits are already set. Up until now, I didn't change any request and any limit about what all I've talked up until now. There was any change. There was no change on any request and any limit. Every pod got exactly the too much resources that you requested. So what I've talked to right now, I didn't touch the resources. So yeah, no performance impact at all.
You know, it's interesting you said this. We see the same across all our users. You should think of this as the following. The problem we solve, we eliminate over provisioning in real time, and then we select the least expensive machine when we can. As long as you supply above the yellow line I was showing to you earlier, then you're fine. That means you supply enough compute, slightly more than you need. And that's what we see with other users. So I didn't know about the Black Friday things. Thank you for sharing that. That was super cool. I didn't know it was the smoothest in the last 10 years. So thank you.
I really wanted to ask Scott again, like you see a lot of organizations. I see another question over there, but I want to ask for Scott first. Like, Scott, what do you see as key requirements from other organizations? What do you see?
Well, they want to save money, right? So whatever tool enables them to save money and get an ROI, right? They need to save money and it needs to work. That's basically it, right?
Yeah. So for us, like the biggest expense in Yotpo, following of course human resources is cloud hosting. That's the biggest expense. Out of cloud hosting, the biggest expense in cloud hosting is compute. That's how it's for us. And for us, just by implementing Cast now, I won't say that implementing Cast was easy. It was not. It was a journey. But by implementing Cast, we reduced about between 30 and 40%, depends on the month, of our compute cost. And our compute costs are not small. They are not small at all. I see some more questions here. Let's see. How does Cast AI fix over provision deployments? Does it update CPU memory request values automatically in real time and force a new deployment? I think, Laurent, maybe you can take that.
Yep, that's how we do it. So we update CPU and memory request. So real time for us means you can change that, but I like to have a window of a few minutes. We by default we look at 30 minutes window, and we do this so that we can look at the latest movement and make an adjustment based on what just happened. But there's a lot of we just don't take an average. I'll give you an example. If you look at a new workload that just started, usually at the boot time, you have a much larger increase of CPU when it boots, and then it goes down over time. So we ignore that piece. You want to ignore that piece because it's not relevant. It's not really representing the cluster or the container. So there's a lot of AI study that goes there. Do you take the average, but not really? When do you take it? When you don't? Also, you have some very spiky workload, but the good thing with CPU, it's elastic. So it's okay to go above the requested amount. It's not okay for memory. So you see we train the engine very differently when it looks at CPU and when it looks at memory. when you do it this way, then you have then the performance side. I mean, you heard Ari, disappears. Right? It's not anymore a concern because it's a real-time engine that supplies more if it needs, but is very, very smart in how much more or how much less, separately from CPU than memory being more important than CPU, but also being a lot cheaper than CPU. So that's the answer that we have.
There's another question over there, which is, what is the biggest savings you were able to achieve for a customer?
Oh,
Am I the winner, or are there bigger? I am afraid that there are bigger winners than me.
there are bigger ones, Ari. I'm sorry. So look, the absolute biggest one, it's the top scene. It was 92%, but that happens only once. It was on Google Cloud, and the reason is this client was using 100% on demand at the time, even CUDs. Right? So the amount of workload went down by half. Sorry, the amount of CPU went down by half, and then the rest was a spot instance impact on that customer. Yeah, so it's quite exceptional. Like, it's not usually you're a good average.
Yeah, I moved everything to spot the forecast. Sorry,
You
but
did that too. That's right. So
yeah,
that's
I
fine.
have another question over there. I'm not sure that I follow it. I'll read it out loud and let's see if we can answer it. Can we calculate the Kubernetes cost at a granular level, specifically at the pod level, and also at each endpoint level, especially when dealing with multiple endpoints within an API pod? This information may aid in optimization the API endpoint code.
Yeah, it's a great question.
Yeah, I think. Can you take it?
So
I
it's a
can
good.
answer my experience, but I haven't done that at an API endpoint level inside the pod. We've done it in pod level, like service level. That's how we do it.
Yeah, we say most of the users we have do the same. They look at the pod level. So yes, you can track Kubernetes cost at that granular level of the pod. You can do the workload, which is consolidation of pods, but you can also do pod by pod if you want. You can do by namespace. You can take a lot of those variable and sort, or even do it by tagging. But within a pod, going deeper than that I haven't seen. It's the same as you, Ari. I haven't seen that.
But take a question.
I don't know how Carpenter works with Cast AI, so I can't take that question. Yeah.
Oh, yeah. Well, Ari, you used Carpenter before.
So what we've done is, as part of a POC, we have installed both Carpenter and Cast AI together. And the features that we were looking for in Carpenter was exactly what I've told before. Give me, like, for us, like the BFCM, the Black Friday pain point of, give me a spot. If there's no spot, move me to an on-demand. And once there is an available spot, bring it back. So Carpenter was not able to do that. We actually talked with the AWS team that is building Carpenter. We asked them, when are you going to do that? And they tell us, like, oh, it's not in our backlog. So, okay.
Wait a second, I have a question here. Are
Yeah.
you saying that AWS is not in a really big hurry to save you money on your AWS bill? Is that what you're telling me?
That's the big words, Scott. Very, very big words, but we're
Just a
talking about
question.
software development team leader who is leading the Carpenter team, and I simply asked her, okay, this is a feature that I want. When are you going to do that? And she said, not in the near future. Specifically for that feature, specifically for Carpenter. Not don't pick too many, not too big words in my mouth. So we did a very rigorous proofing of all the requirements that we wanted, like which requirement, and we gave actually a score to each one of the solutions that we knew in that particular time frame, and these were the answers that we got. So can it work with a carpenter? I don't know. I don't care. I don't use it.
If I could go back to the network thing, because that was interesting. I also work with a lot of cloud networking companies. But all of these questions are coming up a lot, right? About saving money on compute, saving money on network, saving money on egress data costs, which is another, there's many components to your cloud costs. And not to pick on Amazon, but Amazon by itself is not incentivized to save money on your network costs, right? But if you're using multiple clouds or multiple systems, you need a neutral tool, like a multi-cloud tool that can save you money. And I think the cloud providers are seeing more pressure on this because more people are using switching between clouds, and if they're using multiple regions, they need to manage the data costs between the regions, which you talked about. And so we're going to hear more about this now, and the cloud providers are going to be forced to help the customers find solutions.
Not
And
just
Laurent, I'm curious, I don't know if you've worked with some of the multi-cloud networking companies like Aviatrix and Proximo. They are addressing egress costs and managing how your network, a similar thing, automation of the network costs with automation of the compute costs. I'm curious as to how this will work together in the future. How you think?
Laurent, me.
Yeah,
What are you asking?
you can try. You can start, Ari.
Okay.
View on that one.
Like we are a single cloud. We don't aim to go multiple clouds, so we don't have the multiple cloud network cost issue. And also we have optimized for network cost in whatever we can put in a single AZ, we put in a single AZ. And so we try to do that as best. The visibility on network in AWS is terrible. This is a feedback that I've already received, and I hope that they're working on it. But not just AWS. In Kubernetes, we don't have requests and limits for networks. Like this is a resource that gets depleted actually, and also costs a lot of money. But in Kubernetes, there is no way to have the scheduler consolidate with it. Like every instance has basically an amount of IOPS that it can use. And if it depletes, then there's an issue over there. But right now, Kubernetes itself does not provide the answer. In KubeCon, I actually run after some very big guys in the community, and I asked them, when are you going to do this? This is an issue. Yet to be determined. So bottom line, network is an issue.
Yeah, I have the same view here, Ari. So, and Scott, the multi-cloud thing is still a little bit science fiction when you are thinking of deploying the same app across two clouds. Few people do that. We did see some of them, but not a lot of. We see a good network problem when you want to share data. It's not really an application that live across two places. It's more multiple application that use the same data. The data is in one place. You need to send that to other clouds. I think it's a great discussion and a great frontier. I'd love to know how AWS, Google, and Azure are thinking about it. They are whispering some of this. They are trying to cut, like AWS announced they will cut egress cost, but they only do that if you are leaving AWS. The same for Google. They only cut your cost for network if it is used to transfer data from one place to another. I think this idea of egress or network cost across cloud provider or even between a cloud provider and internet is something they're resisting probably, and they'll have to come clean with this in my mind at some point because it's really expensive.
Laurent, there is one question about look at the question. Can cast forecast and recommend to deploy a given application on one hyperscaler versus another, like Azure, Google Cloud, and I will add AWS?
It's a great question.
Hmm.
I'll answer that question if you guys reach out to me offline. We've done this work for our friends, and yeah, there are big differences. That's the teaser. There are very big differences of running the same apps across between AWS, Google, and Azure. And the differences are more than 40% between the most expensive of the three and the cheapest one of the three. So I'll leave it at that. But please ping me. I know, Ari, you're smiling. So ping me offline if you want to know more about this one.
We have another question. I think that I can take it. What was the biggest concern your team had before picking CAST, and what helped you overcome it? Well, stability. Stability was the main concern. We are changing a cluster autoscaler. Like we are moving out of Kubernetes, open source, cloud autoscaler, battle tested by hundreds of or thousands of people around the world. So for us, robustness was the main concern. And this is why the journey with CAST, like migrating into CAST, it was not like one day and that's it. No, it took few months. It was very slow. Every step of the way, we were verifying that we are not harming our customers and that the uptime is not hurting. So the journey ended basically on Black Friday. CAST was like we had I don't remember how to call it, like a task force specially created for Black Friday to make sure that any issue that will be raised will be fixed very fast. But guess what? Nothing happened. So for me that was like the best experience. It took a while. I wouldn't say that it wasn't perfect. It is like CAST is quite new, but yeah, it's good.
Yep.
Yeah.
Thank you, Ari. There's one question about, I'll reply quickly. Is there any significant cost associated with adding the CAST AI agent to our cluster? No, there's no, there is almost nothing. It's used, I think, what is it, Ari? 0.1 CPU in your cluster? Maybe 0.2 CPUs.
I'm very familiar with my cluster in terms of cost, but I don't remember the amount of how much the agent costs because it's insignificant.
Oh, yeah, exactly. It's almost it's one agent per cluster also, so doesn't matter how big the cluster is.
I love the questions. Keep them coming.
Yeah, it's really cool, guys. Please continue. We have 5 more minutes. I really like this. There was one question from Vincent that disappeared. I think it says answered, but I want to answer it anyway. Vincent asked the following question. I'm trying to find it is how to deal with interference with existing Terraform code. Ari, are you using Terraform?
So we are using Terraform. We're actually using Terraform Cloud, and I don't get what is interfering. Like we are changing the cluster autoscaler. We have still the ASGs just in if we want to fall back to them, they're still there, but there's no conflict. Like I'm not sure that I understand the question.
There's no conflict. So, and we have a Terraform provider for CAST. I think you're using that too. Meaning you can use the UI or you can use Terraform for this.
We are.
So no, it's easy. It's easy to use. We also have its new provider for Upbound for Crossplane.
Oh,
Scott, you know Crossplane?
yes, met with them last week.
Yeah, they're a great partner of us. For those at KubeCon, we did a great party with Crossplane. Long
Fantastic.
party.
Maybe we have a little bit more time. Could you tell us, maybe give us some hints of your roadmap and what we might see this year? How this is.
So I'll tell you a few. There's a few some things I can't say. But we're doing a big announcement for link to LLM, large language model. We're doing that at Google Cloud Next in 2 weeks, so stay tuned. Can't say it, otherwise I'll have my team members angry to me. But yeah, we're doing a big announcement. It's super cool. There's a lot of potential to optimize LLM for many reasons, not always the one we think. These languages are different. They have different costs, different performance, different results. We're able to, and so thinking about LLM and cost is a very difficult problem to solve.
Interesting.
I see a question, but I want to answer it, and maybe you can answer it also.
Go ahead, Ari.
George, I think that the question is, what are your requirements? What do you need? And how does the competitors, like there are several competitors, we just listed them before. And the question is, what do you need? And how does Cast or other competitor, like say, like Carpenter, like Scale-Up, like Spot, how do they answer your requirements? In my eyes, I've done like we worked about this like 2 months before we actually decided with POCs with one of the each one of the competitors, and that was our choice. But I think that this is for you to examine. Maybe
No, it's a great answer, Ari. There are a lot of there are great solutions. Some solutions are nice for observability, so they'll tell you what is wrong. They will not fix it for you, but at least they'll tell you what is wrong. Datadog has a great one. The KubeCost is another one. Fantastic product. In the space of fixing the problem, it's a lot less than Ari, you saw all of them. It's a lot less. To tell you what to do, but not doing it is simple. To fix it for you automatically in real time, in a smart way, right? Without downtime, without performance impact, with a great cost optimization, that's really hard to do. There are not many players in that space. Ari, you mentioned some of them. It is very, very, very difficult to do. There's another question that is kind of similar to this. I'm going to read it. Companies would clearly rather overspend and risk less downtime than optimize their cluster and risk more downtime. Do you think that mentality, will ever shift? And if so, why and when? I think, Scott, you may have seen some of this, no? This mentality of over provisioning, the fear.
Well, yeah, it's this optimization thing. I think whenever you have a new technology, it's difficult to trust. So the biggest challenge in this industry will be building trust of automation. Can you trust it and not lose your job? Thankfully, we've heard good stories from Achi. He didn't lose his job on Black Friday. In fact, hopefully he got a raise. He saved so much money, but yeah, any automation technology has a fear, right? A fear factor.
Yep. And we see this fear. And I think the best way to answer the competition is exactly that. It is the human. It is the fact that us as human, we think we can do it ourselves, and we want to be in control of this. Now we realize there are some great engines, let's call them smart. Some others say it's AI, smart engine that does it for you. Believe me, when you have something that look at these things 1,000 times per second, 24 hours per day, 7 days a week, then there should be no fear that something gets broken because it's checking it 1,000 times.
I think that I think that for us, for Yotpo, again, it took a long time to build the trust. And once the trust is gained, then it's gained. But I think that, again, I will not speak for a lot of companies. I think that this is like Scott's place. I know just my company perspective. And when you try risky stuff, then the question is, how much are you going to gain from it? And what are you losing from it? In our situation, the gain was very high. So we mitigated the risk by testing, by making sure, by simulating downtimes, by testing the autoscaler. And actually, I would say something about CAS support. So CAS gave us like really, really good support, like very, very responsive. Every issue was deeply interrogated, and we found issues. So we did. It's not that we didn't find issues. It's still a new technology, but after several workloads, you're doing the first one, you're scared, but you see the gain. Then you see, wow, the cost of the workload reduced in 50%, 48%. Wow, okay, I must do it more. and then you build this trust, like slowly and slowly. And what else about this question is that 2023 was a harsh year globally, also in Israel, but also globally. And that is the main driver for a lot of companies to take the leap of faith and actually do that. That's how I see it. That's what happened for us. Like we needed to be more cost effective. So we've done it.
Thank you, Ari.
Excellent.
Oh, Scott, do you want to add a few words?
No, I was just saying that was a great description.
Thank you, Ari and Scott. It's a pleasure. Thank you so much for your time. We have some more questions coming. We'll try to reply to them offline. You feel free to. I think I have a page here. Feel free to contact us offline if you have more questions. So if you want some advice on your Kubernetes deployments. Ari, thank you for your experience and for telling us of your stories.
Thank you for reducing my cost.
Thank you. And Scott, for your view of the industry. It's very, very
Thank you.
cool.
Thanks for having me. Thanks.
Thank you, guys.